Let's move to number 7. A fruit salad is made from pineapples, pears, and peaches mixed in the ratio of 2 to 3 to 5, respectively, by weight. What fraction of the mixture by weight is pineapple? Let's take a look at the steps. So we're going to assign those values that they give us in the question for weight. So the pineapple weight would be 2, the pear weight would be 3, the peach weight would be 5. So the total weight is 10. All I did there was just added up the pineapple weight, the pear weight, and the peach weight. So what fraction of the weight is pineapple? Well, 2 out of the total weight of 10 is pineapple, and we can just reduce that fraction. 2 over 10 can be reduced to 1 over 5. So our answer would be A. What fraction of the weight is pear? The answer would be 3 over 10. Let's move on to number 8. In the figure above, square RSTU is inscribed in the circle. What is the degree measure of arc ST? Well, we know that there are 360 degrees of arc in a circle, and a square has 4 even sides. So since a square has 4 even sides, then it's going to evenly divide this circle into 4 equal arcs. So how do we find out the values of those 4 equal arcs? We simply divide the total amount of arc by 4, and we're going to get 90 degrees. So your answer would be C. Number 9. If P and Q are 2 sets of numbers, and if every number in P is also in Q, which of the following cannot be true? All right. So just by looking at the question, all the numbers in P are in Q, but all the numbers in Q aren't necessarily in P. So that means that the Q set is larger than P. So let's put some numbers in as examples. So if Q is the largest set, let's say the P set had the numbers 1, 2, 3, 4, and the Q set had the numbers 1 through 8. We know that the statement holds true in our question, which says every number in P is also in Q. So our numbers show that because we have 1 through 4 both in P and in the Q set. So let's take a look at these answer choices and let's see which answer choices can actually be true, which ones can't. And we want to find the one that can't be true. So the first one we find that can't be true, that'll be our answer. So if we take a look at answer choice A, 4 is in both P and Q, we can just look at the numbers that we have in our example. And we can see that, yes, it is possible for the number 4 to be both in the P set and to be in the Q set. Let's look at answer choice B. 5 is in neither P nor Q. Now we don't have the number 5 in our example for the P set, but we do have it in the Q set. But let's take a look at this statement. The numbers don't really matter. 5 is neither in P, so if we took 5 out of the Q set, the statement would still hold true that every number in P is also in Q. Remember, all these answer choices, and each one of these answer choices, we're simply trying to find out if the statement holds true that every number in P is also in Q. So if we take a look at answer choice C, that answer choice says 6 is in P but not in Q. Well, every number in P must also be in Q according to the question. So we know that C is not correct, because if 6 is in P, 6 would have to be in Q according to the statement. So your answer would be C. Let's move on to number 10. What is the maximum number of rectangular blocks measuring 3 inches by 2 inches by 1 inch that can be packed into a cube-shaped box whose interior measures 6 inches on an edge? All right, so we're going to have a series of rectangular blocks that are going to fit inside a larger cube. So we're going to take the volume of the rectangles and the volume of the cube. Remember, volume equals length times width times height, and cubes, like squares, have equal sides or edges. So the length and width and the height of the cubes would be equal to 6. So the volume of the rectangles is 3 times 2 times 1, which is 6. Those values were given to us in the question. And the edges of the cube were 6, as we mentioned before. So the volume of the cube is 6 times 6 times 6, which gives us 216. So how many of these smaller rectangles can fit into the cube? We simply just take the volume of the cube and divide that by the volume of the rectangles. And we get 216 divided by 6 equal 36. So your answer would be D. Moving on to number 11. If a is not equal to 0 and 5 over x is equal to 5 plus a over x plus a, what is the value of x? So we have an equation here and we want to solve for x. So the first thing I would do is cross multiply. So in cross multiplying, we get 5 times x plus a is equal to x times 5 plus a. So when we get rid of those parentheses by multiplying that out, we get 5x plus 5a is equal to 5x plus xa. We subtract 5x from both sides, so the 5x's cancel out, and we get 5a is equal to xa. Well, the question is asking us for the value of x, so how do we isolate x? We simply divide by a. The a's cancel out, and we're going to get 5 is equal to x. So your answer would be E, 5. Moving on to number 12. The figure above is composed of 25 small triangles that are congruent and equilateral. If the area of triangle DFH, which is the small triangle, take a look at the diagram. So if the area of triangle DFH is 10, what is the area of the large triangle, triangle AFK? Let's take a look at the steps. Triangle DFH contains how many triangles? So if you don't forget the one in the middle. So triangle DFH, the large triangle DFH actually has four smaller triangles within it. So what we're going to do is we're going to create a ratio here. So there are 4 small triangles in triangle DFH, but in triangle AFK, there are 25 small triangles. So we're simply setting up a ratio where we take the part and place it over the whole. We're going to do the same thing with the area, and we're going to set these ratios equal to each other so we can solve for the area of the larger triangle AFK. So the way we set that up is we get 4 over 25 is equal to 10 over x. 10 is the area of triangle DFH, which we're calling the part, and we're dividing that by x, which is the whole, which would be the area of triangle AFK. So similar to how we did last problem, we have an equation, we have an unknown value x. We're just going to cross multiply. When we do that, we get 4x is equal to 250. We want to find the area, which is the value x that we have here. So we're just going to divide both sides by 4, and we get x equals 62.5. So your answer would be E. Moving on to number 13. So you have simultaneous equations here. If the equations above are true, which of the following is the value of y plus z? So let's just take a look at these simultaneous equations. We want to cancel out the x's. Well, they have 3x as the value for the x value in both of these equations. So we can cancel out the 3x's just by subtracting one of these equations from the other. So when we take the top equation and subtract the bottom, we get y plus z is equal to 5. 3x minus 3x, that'll cancel out. 2y minus y will give us y, and 2z minus z gives us z. 19 minus 14 gives us 5. So y plus z is equal to 5. So your answer would be E.